Dear students, in this lecture we will study the solution sets of some equations by expressing one unknown in terms of the other unknown. For example, if we are given x and y, the equation which contains x and y, so that you can have two possibilities. One, you can think of x in the form of y, we call it as function of y, and y in the form of x, we call it as function of x. What is the meaning of solution sets when we study in matrices? The solution set will take some assumption of the values, and right side we know that independent variable and left side symbol is dependent variable, so that you can assign some value and then you must get the value of y, and you can assign some value of y, you can get the value of x, and both you can verify all the solution sets of the equations. That means in the case of two equations and in the case of three equations. So in the case of two equations you can think of two unknowns. In the case of three equations you can think of three unknowns. Two unknowns, how we can explain? One unknown in the form of another unknown, and in the case of three equations, how each unknown can be expressed in terms of the remaining unknowns. For example, in terms of x and y, you will express x in terms of y and y in terms of x. In the case of x, y, z, otherwise x1, x2, x3, you can explain x1 in terms of x2 and x3, you can explain x2 in terms of x1 and x3, you can explain x3 in terms of x1 and x2. Now on the right side you are going to assign some values and you will be collecting the corresponding values. For example, in the case of first equation, that is x in the form of y, you have one variable with only one variable, so that only one variable you can give and two corresponding value you can get it. Okay. Now the second value, because two unknowns are there, second value means one more value of the same independent variable you can assign on the right side, and the corresponding dependent variable value you can get when you have explained as one unknown in terms of the other, and vice versa. Suppose x and y, if you want to express y in terms of x, in the case of such relation, the functional notation will be called as y is a function of x. Y acts as dependent and x acts as independent variable. So we assign by indicating x in terms of some parameter, that means some parameter means some other symbol. You can take it as t or s or r, something like that. Then you can assign the value of t, that is equal to x, that is equal to some number, then calculate the value of y, and so also vice versa. If you express x in terms of y, then you will explain the functional relation, that is x is a function of y. According to the functional relation meaning, y will become independent variable and x will become dependent variable. Therefore, we give the inputs for y and you can collect the corresponding outputs as dependent variable. There also you can get solution sets of the equations. So same thing, we can extend our idea to three equations with three unknowns. Okay, but so where we are getting different types of unknowns means uneven matching. For example, if two equations are given, two unknowns are given, then the system holds good to give the solution. If three unknowns are given and two equations are given, the system will not give the unique solution. That is the basic condition. Let me start. I shall take up two examples on this case. One is two variables with expressing in two types, and three variables expressing in three different types. Okay, the first example which I am taking on the solution sets, directly I am taking the example, and through example I shall try to explain. The first example is like this. Find the solution set of 4x minus 2y is equal to 1. So this is one equation. Suppose I want to discuss with this in two different forms, I can explain. two different forms I can explain means x in terms of y and y in terms of x. So let me start with first the possibility number 1, okay, first case, otherwise case 1, right, that is 4x minus 2y is equal to 1 can be taken as, that is 2y is equal to 1 plus of it is 4x. This implies y is equal to 1 by 2 into 1 plus 4x. This is equal to 1 by 2 plus 4 by 2 into x. So this is our final form. Then you will be getting y is equal to 1 by 2 and 4 divided by 2 means plus of 2x. This is the first rearrangement I can call. This is nothing but y is a function of x. In this case, x is independent variable and y is dependent variable, right. For expecting the solution sets of equations, we assign on the right side, because always the input should be given to independent variable but not to the dependent variable. Okay, independent variable is x, we give the input. So let x is equal to t. X is equal to t means two arbitrary values we can choose, two arbitrary numbers, any number you can choose, but finally you have to match with your solution sets of the computations. Then first value if I take, for example, if it is equal to 3, 1, 2, 3, 4, any number you can take, but for some purpose I am taking 3. I will let you know at the end why I have taken as 3. Then x is equal to 3 implies y is equal to 1 by 2 plus of 2 into 3, that's equal to 1 by 2 plus 6 is equal to 1 plus 12 divided by 2, that is 13 divided by 2. That is first possibility you can expect x is equal to 3, that is 1 by 2, 1 by 2 and here here it is minus, that is with plus sign only. Okay, so this is 13 by 2 for first number. 2y I have written, 2y I have written means here this minus becomes plus sign and this 1 with 2y, okay, and this is minus 1, this is minus 1 and this is minus and this is minus and this is minus, then this is minus and this is minus, this is minus, 6 2s are 12, that is 11 by 2 we are getting. So the first number is 11 by 2. Now another choice you take, let x is equal to t is equal to minus 1 by 2, then x is equal to t is equal to minus 1 by 2 if you take, then y is equal to here minus 1 by 2 and in place of 2t, that is 2 into minus 1 by 2, that is equal to 2 into minus 1 by 2, then you will be getting, that is y is equal to minus 1 by 2, 2 cancels and minus 1, that is equal to minus, it is 3 by 2. This is the answer. So for this is for the relation, functional relation y is equal to f of x. So y is equal to f of x, two values you are going to assign, even any two other numbers also you can also introduce. Now for the first two numbers which I am getting, one is 11 by 2 and the another one is, that is minus 3 by 2. So solution set, you can club the solution set in the form of a table like this, because your equation is y in terms of x, therefore x and y and x and y, okay, y is your equation. What is that equation? It is minus 1 by 2 minus 1 by 2 plus of it is 2x, right. So for this there are two values which I have assigned. First value is equal to 3, I am able to get 11 by 2 I am able to get 11 by 2, and the second value I am assigning minus 1 by 2, I will be able to get this calculation as 3 by 2. So it is just like simple graph which you are going to explain. Okay. Now this is the case 1. Now second case, otherwise possibility you can write. Now the same equation which you can take it as in another form, that is, instead of y equal to f of x, you can take it as x equal to f of y. Therefore the given equation is minus 2y and that is equal to 1. 4x minus 2y, that is equal to 1, can be taken as 4x is equal to 1 plus it is 2y. This can be taken as x equal to 1 by 4 plus 2 by 4 and y. This is equal to 1 by 4 and plus of 1 by 2 into y, 2 into y, okay, that is right. This is for x. So this clearly indicates x is a function of y. X is a function of y means here y is the independent variable and x is the dependent variable. Okay. So here you can write it as same thing, x is dependent variable and y is independent variable, because right side symbol inside the bracket is always the input, and left side which depends on it we can call it as dependent variable. Okay. So now we shall substitute the values for the input as y on the right side. One choice which I can take it as, let y is equal to, that is 3. If you take, then x value, x at y is equal to 3 is equal to, x at y is equal to 3 is equal to 1 by 4 plus 1 by 2 into, that is 3. Therefore here 4 is the LCM, that is 1 plus 2 3s are 6, this is 7 by, it is 4. Then, and another choice you can take, and y is equal to minus, it is 3 by 2, some number you can take. Then x at y is equal to minus 3 by 2. Therefore that gives 1 by 4 plus 1 by 2 into minus, it is 3 by 2. Then that becomes the LCM, that is equal to 4 and 1 minus 3. That 1 minus 3 means it should be, that is minus 2 divided by 4, that is equal to minus 1 by 4. Minus 1 by 4 is the final answer for the substitution of y is equal to minus 3 by 2. Then the solution set for this is, that is x and then y. Here y is the input you are taking, that means x is a function of y is the independent variable and x is the dependent variable. So x is equal to y is equal to 3 and y is equal to minus 3 by 2. Suppose you take these two values and then if you write the solution set in this way, that is at 3 you are getting, it is 7 by 4 and another one is minus 1 by 4. So these two are solution sets. What you have to understand is, in all the three cases solution sets are totally different. Those values are different and these values are different. This is the way where two variables are connected for the solution set of the equations. Now another the next case I am going to take it as with the three variables, how the solution set we can find out. Find the solution set of, here I will write a different equation, that is x1 minus 4x2 plus 7x3 equal to 5. Here this is the case of three variables, and how you are going to take the rearrangement, it all depends on which symbol you write in the left side and which symbols you are going to write on the right side. Then you can assign the numbers then solution sets of the values you can collect. Okay, then the first possibility from the equation, since it contains three variables, then only thing is that this is all trial values which you have to assign, and the corresponding calculated values you have to get it. Okay, what are the trial values you are going to write? Trial values depends on x1 in terms of x2 and x3. Trial values depend on x2 for the input of x1 and input of x3. Trial values depend on x3 for the input of x1 and x2. So three possibilities you can calculate. Okay, so what is the equation given now? Given that x1 minus 4x2 plus 7x3 is equal to 5. This is our basic equation given. Okay, so now I will write three possibilities from this equation. Implies now x1 you can write that is equal to 5 plus 4x2 minus 7x3. This is one possibility, right? This is one case. Here itself I will write. Next, 4x2, that means x2 can be expressed as 1 by 4 5 minus x1 plus 7x3. This is the second case, right? Another possibility which you can expect, x3 is equal to, it is 1 by 7 multiplied by 5 minus x1 and plus 4 x2. So these are the three possibilities. That means this is the case 1, this is the case 2, and this is the case 3, right? Case 3. So in all the three cases we give the inputs by defining the functional relation properly. What is the functional relation here? In the first case, this is x1, means x1 is a function of x2 and x3, right? And here this one x2 is a function of x1 and x3, and here x3 is equal to function of, that is x1 and x2, x1 and x2. So these three possibilities will be taking, here x1 is dependent variable and x2, x3 are the independent variables, right? Here x2 is the dependent variable and x1 and x3 are the independent variables. Here x3 is the dependent variable and x1 and x3 x2 are the independent variables. Now what values you are going to assign for these three equations, you will get the corresponding solution sets. Now the first one, suppose I take the first, but in the previous case only one value was there, which was the equation like x and y, but here right side there are two values. You have to give two inputs on the right side and corresponding output you have to get it. For example, the first case if I take, then x2, x1 in terms of x2 and x3, let x2 is equal to 2 if I take and x3 is equal to 3 if I take. These are in a different symbol, therefore x1 I am getting it as minus 8, you can verify. Then similarly that is here 5, okay, right. Here in the second case x1 is equal to 8 if I take and x3 is equal to 3 if I take, then I will be able to get x2 is equal to 6. This you can check. This is the solution set. Okay. So now here for x3, then x1 is equal to 8 and x2 is equal to 2. Then x3 is equal to 5 by 7. You verify this one, if there is any change in that number, you can write the correct value for that. Anyway, solution set in this form I can write for all the 3 tables, I can write for all the 3 as I have written in the previous example. For the first one, the inputs are, that is x1 I have to write at the end, because x1 is a function of x1 is a function of x2 and x3, and x2 is a function of x1 and x3, and x3 is a function of x1 and x2. Okay, so what I have to write now? This is x2 and x3 are the inputs, x2, x3, and then what is that? X1. What is the calculation I am getting for this? For the input I am getting, I am taking, like x2 is 2 and x3 is 3, this is minus 8. This is one solution set. Then here, what is this? x2, x1 and x3, x1, x3 and x2. Based on this, dependent and independent variable values 8, right, and another one is 3. I will be able to get this one as 6. Next is this is x3, means x1, x2 and x3. You can collect the values from this as solution set, that is 8 and 2 and then 5 by 7. So these 3 are the solution sets of the values. So first system, x1 is dependent variable, second system x2 is the dependent variable, and third system x3 is the dependent variable. So there are 3 tables which we can expect as solution sets, but all the 3 are different. Here 2, 3, minus 8, here 8, 3, 6, here 8, 2, 5 by 7, and it is quite obvious, because the reason is here only one equation with 3 unknowns. One equation with 3 unknowns means you cannot get unique solution, because the mathematical condition holds good. Always mathematical condition holds good means equal number of equations with equal number of unknowns will give the unique solution. But here we have, this is 3 unknowns and only one equation. So 3 unknowns and one equation means unique solution will never exist. What we have to take? That means by assigning trial values. These are the trial values, x2 equal to 2 and x2 equal to 3 and x1, x3, 8 and 3, like that. Just like that, any set of values you can give. So in this way you can even extend the idea for getting in place of 3 unknowns, you can also extend for 3 unknowns, 4 unknowns, 5 unknowns, like that. So what the values you are going to assign on the right side, that all depends on the calculation for the dependent variable. For example, this is the dependent variable, and x2 and x3 will all depend on what the inputs you are going to give. What the inputs you are going to give means, that is what the values you are going to assign. Accordingly, the corresponding dependent variable values will take the calculation. So this is all regarding the solution sets of the equations. Now the next discussion on the continuation of this rank of the matrix, the consistency and inconsistency of the system of linear equations solutions, how we are going to discuss in various ways. That is our next discussion. That is with the title as system of linear equations. System of linear equations by verifying consistency using rank of coefficient matrix and augmented matrix. Coefficient matrix and augmented matrix. This is the important topic where all the previous information we are going to utilize in declaring the solution for the system of linear equations. Okay, in the engineering problems, most of the cases system of linear equations will be the important requirement where we need to find out the values of the unknowns using matrix method. If two equations or three equations are given to us, then easily we can solve for three equations using Cramer's rule with the condition that determinant is not equal to 0. But Cramer's rule has got some limitation. Now, the consistency we are going to find out using the elementary row operation. As we have studied in the previous discussion, the elementary row operation, now we will utilize that elementary row operation. But let us discuss what is the meaning of consistency and how this consistency is going to check the solution for three different cases. For three different cases means those three different cases are unique solution, no solution, infinitely many solutions. These three are the very important discussions in our syllabus. Then we have to use the rank by comparison of the coefficient matrix and the augmented matrix. This is coefficient matrix and the augmented matrix. So what is the meaning of coefficient matrix and the augmented matrix? In the case of three unknowns and three equations, in the case of the four unknowns and four equations, and you need to calculate the rank of coefficient matrix and the rank of augmented matrix. If they are equal, and we will compare the number of unknowns with the rank of the matrix, the number of unknowns with the rank of the matrix is equal, not equal, and less than the number of unknowns. So these three cases are very important. So now I shall write symbolic wise first, afterwards I shall solve the problems. Now, system of linear equations. For example, I am taking three equations with three unknowns. Define a11x plus a12 that is like xyz if I take, define, and a13 that is z is equal to b1. For example, three unknowns I am going to take, because I shall discuss later. I can extend my idea for four unknowns. Next, a21 x plus a22 y plus a23 z is equal to b1. a31 x plus a32 y plus a33 z is equal to b3. This I will call it as equation 1. Why we call these equations as linear? That you have to understand, because I am sure that you are good in geometry, that is the equations, these words which we are using, linear, non-linear, linear, non-linear, quadratic, cubic, like that. So linear means the degree is 1, degree of x is 1, degree of y is 1, and degree of z is 1. So which equation takes the variables with the degree as 1 throughout the equation, it is called linear equation. It is nothing but straight line. So this is a straight line, this is a straight line, this is a straight line. But in matrix, these straight lines will form the meaning every symbol is having the degree as 1. Okay. So now these are the system of three equations with three unknowns. I can call it as, for example, three equations and three unknowns. Unknowns, which are those? Unknowns are x comma y comma z. So this implies in matrix form, as, so matrix form as matrix equation, that is Ax equal to b. This is your most fundamental equation, Ax equal to b. What is A? A is called coefficient matrix and X is called column matrix for unknowns, that is X, Y, Z, and B is called column matrix for the constants. Now, I shall write this in the matrix form with notations, that is A11, A12, A13, A21, A22, A23, A31, A32 and A33 and multiplied to X, Y and Z equal to, that is B1, it is B2 and it is B3. This is the matrix equation. Okay. When this is the matrix equation in the form of Ax equal to B, this is A, this is X and this is B. This is called, A is called coefficient matrix, X is column matrix, X is called column matrix for the unknowns, and B is the column matrix for the constants, That means column matrix for the constant means constants means B1, B2, B3. So this is your matrix equation. Fine. Now, what is the consistency? Now, this is our target, what we are going to understand, and the rank. So, this is the coefficient matrix, and the augmented one I am going to define the augmented matrix as A double dot B is equal to, we are introducing this B1, B2, B3 inside the coefficient matrix, that is A11, A12, A13, that is A21, A22, A23, A31 and A32 and A33, here dot dots B1, B2 and B3. This is called augmented matrix. Some authors they use this symbol to represent augmented matrix, some authors they use other than this type. Both are okay, but the column for the constants is to be inserted in the coefficient matrix to make it as augmented matrix. That's the meaning. That means coefficient matrix, here it is 3 cross 3, 3 cross 3. Now augmented matrix becomes 3 cross 4. This is square matrix and this is non-square matrix, because square matrix is here in terms of coefficients of A's, and augmented matrix is in terms of A's and B's. B's means B1, B2, B3. Now we find the rank of these two matrices, and if the ranks are same from these two, one type of solution. If the ranks are not same, another type of solution. If the ranks are not same, if the ranks are same and we will compare the number of unknowns with the rank order, then the solution will be different. Okay. So, three kinds of arguments we are going to claim for solving the system of linear equations. Now, the next three important points what I am going to write, they are very useful in solving the problems, because all the three varieties I will be taking the problems. Now, what is the rank of coefficient matrix now? Coefficient matrix, it is, the order is 3 cross 3 coefficient matrix. Now I will write the case 1, otherwise by applying row operations, to the equation 1, otherwise to Ax equal to B. You can write matrix equation Ax equal to B, and if first case. Now I will write first case. Okay. What is that first case? For this example, this is, you can call it as equation 2. Then first case, if rho of A is equal to rho of AB, this is coefficient matrix rank is the same as rank of the augmented matrix. Then here R is the rank, okay, R is the rank, is equal to N is equal to N is number of unknowns, right, number of unknowns. In this case rank should be 3, that is 3 equal to 3, that means rank of A is equal to 3 and number of unknowns, that is equal to N, and rank is equal to N, okay, 3 is equal to 3, and if this number is also 3, this number is also 3, coefficient matrix rank is equal to 3 means A33 is not equal to 0, that is all. That means these two elements by row operations we make them as 0, but third element will not be equal to 0. Therefore, this implies rank of A is equal to rank of AB, rank of A is equal to rank of AB implies the system is consistent, the system is consistent implies there exists a unique solution. There exists a unique solution. What do you mean by unique solution? Unique solution means it's a number for X, number for Y, number for Z. That means only one particular solution will exist. Unique solution means single solution. Otherwise, single solution you can write. In which case, that is rank of A is equal to rank of AB, that is equal to 3. That's equal to 3 in this case, because example I have taken as 3 cross 3. So this is the first discussion. Now second discussion. If rho of A is equal to 2, right, rho of AB, that means rank of AB is equal to 3, then rho of A is not equal to rho of AB. This implies inconsistent, and this implies no solution. So we don't solve for this case. When ranks are not same, we don't solve. This is the second very important condition. Now the third condition. Third is very important. Again, third condition, if rho of A is equal to 2 and rho of AB is also 2, and if that is rho of A is equal to 2, that means R is the rank, R equal to rho is less than N, the number of unknowns, right, the number of unknowns. Though it is consistent here it is consistent, but implies solution solution as infinitely many solutions. Infinitely many solutions. So, you remember these three very important cases. One is ranks are same and equal to the order, there exists unique solution, and ranks are not same, there exists no solution, and ranks are same but still r is less than rho, sorry, r equal to rho less than n, the number of unknowns, okay, then it is consistent but solution will be in many number, because that is z equal to 0 by 0 you are getting, that I will show in the problem how this meaning matches. Z equal to 0 by 0 means it is indeterminate form, then we will take it as some parameter k, k may be negative, k may be positive, k may be 0. So, negative and positive means infinite number of solutions. So, this is the very important material as far as consistency of the system of linear equations is concerned. Now, based on this information, I will solve for totally 5 different very important examples, and first example is a direct approach, how we can calculate the values of the unknowns, and second example may be second case, third example may be the third case, and next two examples are of a little different type, where all these three informations will be put together. So, first example I will take on the solution of system of linear equations. That linear equations will be, example I am writing on the application of this information, test for consistency and solve the system of linear equations. That is first equation, x plus 2y plus 3z equal to 1, 2x plus 3y plus 8z equal to 2, x plus y plus z equal to 3. Not necessarily these equations, any three equations you can assume, and if you go to exercise of various textbooks, you will find plenty of problems. This is one maybe some standard example to the direct approach I am taking as of case 1. Okay. So, these three equations we have to solve. Using Cramer's rule also we can solve this one, not by verifying the consistency, Cramer's rule, but in the case of Cramer's rule, you have to verify the determinant should not be equal to 0. It should be in the non-singular form. Okay. So, now I shall start this with the matrix method, and which case is going to be applied among these three cases just now we discussed, which case is suitable for this, let us verify. But the question is common, test for consistency and solve, question is common for all the problems. That means we have to verify, and you have to write in the matrix form. In the solution, in matrix form, we have Ax equal to B. This is our most fundamental representation. Even in the vector space also I will be considering like this in the next discussion. That is Ax equal to B. That should be 1, 2, 1, 2, 3, 1, 3, 8, 1, and x, y, z, that's equal to 1, 2, 3. This is in the matrix form. These three equations are in usual form. Now I will write those three equations in the matrix form. Okay. So now I have to find out the rank of the coefficient matrix and the augmented matrix. Now, it is not necessary to take separately the augmented matrix, but as it is you can apply elementary row operations, keeping this as undisturbed, this column as undisturbed, and operate to make these two elements as 0 with the help of 1, operate this element with the help of 3, then what are the corresponding changes appear simultaneously in the rest of the columns. Then after making those changes in the rest of the columns, then you can reconstruct the equations, and then you can separate the values of the unknowns. Let us check that. Now, by elementary row operations, otherwise by row operations. By row operations, so we take this two elements as 0 with the help of this pivotal element. Now, so one basic observation which you have to think of, the pivotal element always should be non-zero number. Here the pivotal element is 1, which should be non-zero number, that is 1 which is not equal to 0. Coincidentally, we can proceed for the row operations for the next step. 2 and 1, okay. So I will take like this, minus 2r1 plus r2 affecting on r2. Already we discussed in the calculation of the rank in the previous set of problems, and the same principle I am going to adopt here also. Here 2 is there, I must expect minus 2 here, then previous one I multiply, next one I am not disturbing. Minus 2 r1 plus r2 is equal to affecting on r2, minus r1 plus r3 affecting on r3. This is one choice. Another choice you can take r1 minus 1 by 2 r2 affecting on r2, r1 minus r3 affecting on r3. That also holds good. Anyone, but not both at a time. Any one choice you take and then proceed. Okay. So now this is equivalent to, I am writing 1, 2, 3 undisturbed, right? X, Y, Z column matrix undisturbed. Then right side, first you have to write the number 1 as it is. Now you have to see the changes. Minus 2 r1 plus r2. Minus 2 into minus 2 means minus 4 plus 3, that becomes 1. Minus 2 into 3 minus 6, that is plus 8, that becomes 2. Minus 2, this becomes 0. Minus 2 r1 plus r2, 1 into minus 2 plus 2, that becomes 0. This is 0. Minus r1, that is minus r1 means minus 2, this is minus 1, and minus r3, minus r3, minus r1 means minus 2, this one, okay. Now, so minus r1 plus r3, minus 3 plus 1, that is minus 2, right. And now here, this is 2 and 3 you have to operate, correct? This is 0, already we have done the first one, minus r1 plus r3, this becomes 2. So now our pivotal element will become minus 1, which is non-zero, and this number in the corresponding column is to be converted as 0. How to make it as 0? With the help of previous multiplication, that is minus of r2 plus r3 affecting on r3, because both are minus. This one we have to make it as plus without disturbing the next element, okay. This is equivalent to first two rows will remain same, 1 0, 2 minus 1, 3 2, and x, y, z, and this is equal to, this is 1 and it is 0. Second element also will remain same, and this is 0, this we made it as 0, minus r2 plus r3, that is minus r2 means that is minus 4, minus r2, this becomes plus 2 as it is remains, okay. So now it is very clear how many non-zeros are left. This is anyway coefficient matrix A, and if you insert this column as a fourth column, that becomes the augmented matrix. So in the case of augmented matrix, when one's coefficient matrix itself is rank is 3, number of non-zero rows rank is 3, irrespective of this, it is rank is 3 only for the augmented matrix. That is no need of taking into consideration here whatever the number is there, but here this is non-zero row. Okay. So now how we are going to claim? Implies rank of A is nothing but row of A is equal to number of non-zero rows, that is 3, that is rank of augmented matrix, that is equal to row of AB is equal to what? Is equal to, that is 3 is there, right, rank of that is also 3. Therefore, row of A is equal to row of AB. AB implies consistent. That means consistent means the rank is nothing but the order of the matrix. Order of the matrix means 3 cross 3. That means R equal to 3, N equal to 3. This implies R is equal to N. R is equal to N means there exists a unique solution. There exists a unique solution. There exists a unique solution means single solution. Okay. Single solution means immediately you can reconstruct the equations by, it is called back substitution. By back substitution, you can form the equations row into column, that is x plus 2y plus 3z is equal to 1, and minus y plus 2z is equal to 0, and minus 4z is equal to 2. Therefore, z is equal to minus 1 by 2, and substitute this minus y and plus of 2 into minus 1 by 2 is equal to 0, then y is equal to minus 1 and z is equal to minus 2, then the first equation gives x is equal to 1 minus 2y, 2 into that is minus 1, and z means minus 3 into z value minus 1 by 2. So that is equal to 1 plus 2 and plus of it is 3 by 2. This is equal to 2 plus 4 plus 3 divided by 2. 4 plus 2, 6 plus, that is 9 by 2. Therefore, x equal to 9 by 2, y is equal to minus 1 and z is equal to minus 1 by 2. So this is the solution. By consistency, comparison of consistency, we can find out the rank of coefficient matrix and the rank of augmented matrix, both are same. Then there exists a unique solution like x equal to 9 by 2, y is equal to minus 1 and z is equal to minus 1 by 2. I shall continue the problems in my next class. Thank you.